Assalamu alaikum students, Adil sir here, welcoming you again to this online course of mathematics. As you know that we are following the method of substitution, and in the method of substitution today we will discuss some special type of integrals that need some special attention in order to get solved. So our first integral is beta, that is 1 divided by ax square plus bx plus c. If we have integral like this, how we can solve this and how we can use the substitution method here. Now beta, I will write some steps here. You have to follow them, you have to note them first, and after that you have to follow them if you are concerned, if you are curious to find out these type of integral. So first one beta I am taking as this 1 divided by the general quadratic equation. So beta, first step, from this integral you have to first take this a as common factor, as common. So first you write step, take a कॉमन, इसको आपको कॉमन निकालना पड़ेगा. When you will take this a common, you will get beta here. Take a common, we get take a common, and when you will take this a common beta, what you will get beta? You will get here a into x square. Now the quotient of x becomes beta unity. It has no unity quotient. The quotient of x was this a, but when we take this a as common, we will get after that the quotient of x square as 1 beta. So beta, and make quotient of x square unity. We have to make the quotient of x square unity. That is beta, we get this 1 divided by x square plus bx plus c. We get it as beta. When we will take this a common, it will be here 1 divided by a. Now integral of dx divided by, well, it was a. Now we have make this a common. Here will be now x square plus b, but we have taken this a as common, so here it will be b divided by a x, and after that it will be plus c divided by a. This is our first step. You have to follow it. What we have done in the first step beta, we have taken this a as common, and after that when we take this a common, we get the quotient of this x square unity, and then beta we got our integral of the form this 1 divided by a dx divided by x square plus b divided by a x plus c. This is our first step. Now second step beta. Second step. Step number second. उसके बाद आपको क्या करना है बेटा? Now complete the square. We know that beta, for the factorization of the general quadratic equation, we have three methods. First one is beta splitting of middle term, and then we know the another is general quadratic equation, general quadratic formula, and the third one is beta completing the square method. The method of completing the square, we will follow that method here beta. Now we will write here beta, complete the square by adding and subtracting by adding and subtracting. What we are adding in completing the square method? We are doing this quotient of x, we are dividing it by 2, and then we take beta it as square. So this is our, so we will make this here, we will add this to this denominator. So complete the square by adding and subtracting 1 divided by 2, this quotient x का whole square, we get, what we get beta? We get our integral dx divided by ax square plus bx plus c. But here we have now quotient beta, quotient of this x, we have that beta, we know that our integral this it has been changed to 1 divided by a dx divided by a divided by x square plus b divided by ax plus c. Now we have to add and subtract this integral by 1 divided by 2 quotient of x, that is beta now b divided by a, and the square of that very thing. So we will write it, it will become beta. In first step we got 1 divided by a as common, and after that we have dx divided by x square plus this b divided by a, x b divided by a, x plus c. And now in the second step we are adding and subtracting, plus we are adding and subtracting 1 divided by 2 quotient of b, that is quotient of x, that is beta b divided by a whole square. We are adding it as well as subtracting b divided by a whole square. This is our third step. Second step beta, in the first step we are taking a as common, and in the second step we are completing the square by adding and subtracting the quotient of adding and subtracting the square of quotient of b divided by a 1 divided by 2 b 1 divided by 2 this quotient of x ka whole square. We are adding that and subtracting as well, and we are getting in the second step beta our integral is 1 divided by ax square plus bx plus c. We are getting it equal to 1 divided by a integral of dx divided by x square plus b divided by a x plus 1 divided by 2 b divided by a ka whole square minus 1 divided by 2 b divided by a ka whole square plus c. We are getting this. We are getting these things better. Now third step. In third step what you have to check better? You have to make now better these three, you have to compare them and you have to make them as a square of some number. Better you check here, it is a square plus b square plus 2ab, that is beta a square plus b square, but a we have here. Now in the third step we will make it as a pair, so beta express now beta, we have to express this as a sum or subtraction of two squares. Beta this will become as x express, or we have this beta a c divided by a. Okay, so express denominator now, denominator as the sum or difference of two squares. We have to express that. So we will get here beta, this our integral, we will get it, fourth step we will get it as integral of 1 divided by a x square plus bx plus c is equal to, we will get it as dx 1 divided by dx. This one is a plus b का, that is beta x plus this 1 divided by 2 b divided by a का whole square, and this one will get beta under root c divided by a minus 1 divided by 2 under c minus 1 divided by 2 b divided by a का whole. We get this as this. Of this it is understood better. Now here we will get beta. When we will solve it beta, it will be like beta. Of solving, you have to make this also as square. So I will take it beta as L square, because I have to solve this. So I will take it as L square. So now beta. After that beta, you have to use the formulas we have beta. Dx divided by x square plus a square. This is our formula. This one is also our formula, dx divided by x square minus a square. Or another one we have dx divided. So after this, you have to apply these three formulas beta. So what we have done beta? If we have an integral that is of the form dx divided by general quadratic equation, then we have to solve the quadratic equation by the method of completing square, and after making the denominator as a sum or difference of the squares of two numbers, two numbers, we are applying after that the general formula, the three general formulas. Now beta, this is our. So we will solve one example that will make you understand it easy. If we have an integral beta that is of the form dx divided by 9x square plus 6x plus 1. So I have to solve this beta. I will take this I solution beta. So what is our method beta? First we have to take this the quotient of this x square as common. So here is 9, we will take this 9 common, and we will take the 9 common. Here it will be x square plus 6 divided by 9x plus 1 divided by 9. After that beta, we have to complete the square. We have to complete the square by adding and subtracting 1 divided by 2 times the coefficient of a square divided by 9. So here we will get dx divided by x square plus 6 divided by 9. It will be beta here 3 2 and 3 3 9. That will be beta here 2 divided by 3x, and we have to add by 1 divided by 2 quotient of x, that is beta 2 divided by 3 ka whole square, and we have to subtract it also. So 1 divided by 2, 2 divided by 3 ka whole square, and the last one is 1 divided by 9. This is our now. Now after that, when you will check, you have to express now this denominator as the sum of the squares of two expressions. Beta, here you check, it is dx, but here it will be a square plus b plus 2ab plus b square. It will be a square plus b square, that is beta x square. 2 and 2 cancel out. This 2 x square plus 1 divided by 3 ka whole square, and these 3 we are done because it is equal to this. After we will write this, we have to make this as a square now. Here it is beta 1 divided by 3 minus 1 divided by 3 ka whole square plus 1 divided by 9. So it will be further equal to now we're getting I equal to this dx, but 1 divided by 9, we have also 1 divided by 9, dx is divided by this x plus 1 divided by 3 का whole square minus 1 divided by 3 का whole square, that is beta 1 divided by 9, and then we have plus 1 divided by 9. This one and this one will get cancelled. I is equal to 1 divided by 9 integral of dx divided by x plus 1 divided by 3 का whole square plus minus 0 square is 0. So now what you have to apply the formulas beta. These three formulas, dx divided by x square plus a square or dx divided by x square minus a square or dx. Now beta, here we have this a square equal to 0, or so we can apply all the three formulas here. So beta, if I will take this under consideration, I am getting here beta a as 0. So a square I am getting nothing here. Now beta, I can solve this by so many methods. Beta, we know that we can solve this by taking this to numerator and then applying the formula, this x raised power n, integral of x raised power n. We can also solve this integral by the method of these formulas. Now beta, we will simply follow the method that is best suitable. We can also substitute here beta, this x plus 1 divided by 3 to some t. We are doing in the substitution method. We will here, so we will put that x plus 1 divided by 3 is equal to t. We will get dx is equal to dt beta, and when we put these values back to the I will get 1 divided by 9 dt divided by t square, and it will be further equal to beta 1 divided by 9. This t square, it will come to numerator, but the power will be minus 2 and dt, and by the formula of this integral xn, we know that it is equal to x raised by n plus 1 divided by n plus 1. So power here, it will be 1 divided by 9 t minus 2 plus 1 divided by minus 2 plus 1. So it will plus now c, so it will be now minus plus minus 2 minus 1, that is 1, that will be minus 1 divided by 9, and after that we have t minus 1, it will be plus c, it will be now equal to, we are getting I equal to beta 1 divided by 9 minus 1 divided by 9, and then t minus 1 plus c, it is equal to beta minus 1 divided by 9 1 divided by t plus c, but we know that we have taken this t as x plus 1 divided by 3, so it will be x plus 1 plus c. This is our answer beta to this. So it was a simple example for this method that we remark first beta. Now we are going to make the solution of second remark. Or second remark beta. Remark second. Remark second. Now if we have integral of the for integral of the form integral of the form dx divided by under root of ax square plus bx plus c. Now if we have the quadratic equation that is in terms of root beta, so how we can solve this? We are going to write the steps beta. Step first to beta, you have to factorize this ax square plus bx plus c by the method of completing the square. As we have done in the first integral, you have to do same to this general quadratic equation, and after that you have to beta. So what step first? After that beta, you have to apply beta. Step first, you have to factorize this just same as we have done in the first in this integral, in the first integral, first case. Now here you have to do beta. After that you have to apply these types of formulas beta. dx integral of dx divided by under of x square plus a square. Also we have beta dx divided by, these already we have done beta. These are the formulas under x square minus a square, and after that you can also apply this beta dx sometimes x under x square plus. So we will do one example that is based on this integral. Yes, beta, we will take this. एग्जाम्पल नंबर सेकंड बेटा, जो आपको सेकंड मेथड समझाएगी वही एग्जाम्पल मैं लूंगा बेटा. इफ वी हैव इंटीग्रल I इक्वल्स टू dx divided by under root of, I will take simple example now, x square minus 2x plus 4. So solution beta. The first step in finding the integral that are of the form this. So we know that we have to make, in first step we have to make the coefficient of this x square unity, but fortunately we have already the coefficient of this x square as 1, so we will follow now second step. I is equal to beta integral of dx divided by under root of, we know then what we are doing in the second step. In the second step we are adding and subtracting 1 divided by 2 coefficient of x का whole square. We are adding by this. So what is it now beta? 1 divided by 2 coefficient of x, that is beta minus 2. Minus 2 का whole square. So we will add by this. It will come out as beta 2 and 2 will get cancelled, it will be as beta 1 square. So we will add and subtract by 1. So in the second step we have to add beta 1 and we have to subtract 1 also. So here it will be x square minus 2x plus 1 square we have to add, as well as we have to subtract it, plus 4. And in the final step we are making this expression as the sum or difference of two squares. So here it will be beta dx. When I will look to this expression, it is beta a square minus 2ab plus b square, that will be a square minus b square, it will be x minus under root of x minus 1 का whole square. And after that beta, it is here minus 1 plus 4. Now we have to make both these squares, so we will write it dx divided by, this is x square x minus 1 का whole square minus 1 plus 4, that will become 3 plus 3. But 3, how we can make that? If we have plus 3, how we can make it as square? We can write this as beta under root 3 का whole. So here it will be plus under root 3 का whole square. Now we have this under root 3 as a and this whole as x. So or we are getting here beta I is equal to dx divided by y square by y is beta x minus 1 plus a square, but this a is equal to under root 3. So here we will apply now the formula. We are getting I beta equal to dx divided by under root of y square plus this a square, where y we have taken as x minus 1 and a we have under root 3. We know that this is our formula, this is our standard formula which we have proved already. So that is equal to beta that is log of x, that is beta this y, and we will y, that is log of y plus under root of y square minus a square plus c. So it will come out as log of, but y we have x minus 1 ka whole square plus this under root of y square, that is beta x minus 1 ka, y we have x minus 1, this formula, this y we have x minus 1 plus y square we have x minus 1 ka whole square, and then we have plus this a square, that's beta under root 3 ka whole square, and plus, see, when we will after this will be log of x minus 1 plus this and it will be beta. When you will solve this, it will come out as x square minus 2x plus 4. This is plus c. This is our solution of this integral. Now it was our second type of integral. Now we will go for third one. Now, if we have an integral of the form, you have to write down the steps by yourself. I will just tell you because the time is running now beta. If we have integral that is of the form dx, this ax plus b divided by ax square plus bx plus c dx. If we have integral that is of this form, we have in the denominator we have quadratic, but in the numerator we have linear. I explained how we can solve that beta. You have at that time method you have to substitute this ax plus b, put ax plus b is equal to beta. You have to put it as lambda times derivative d by dx, derivative of the d by dx of this denominator lambda times d by dx of denominator plus mu beta. You have to make this substitution, and after that beta, when you make this substitution, you have to compare the the quotient of this x on both sides, and you will get there beta the value of lambda and mu. You have to compare the quotient of lowest term, you will get the constant as well as this linear. You will get the values of this lambda and mu. When you will get the values of these two, after that you will put in your integral and you will get a solution. We will solve one example that is based on this beta. complete it because we have to go for this method of what is we call it? Method of integral by parts beta. We have to get there very soon because the time is running. Now we will solve some one example that is based on this substitution. If we have an integral that is of the form beta this I is equal to 2x minus 3 divided by x square plus 3x minus 18 dx. How we can solve? As you already I have given you that beta, if we have quadratic in the denominator but linear in the numerator, we have to substitute this numerator, put 2x minus 3 is equal to beta, what I have told you, lambda times derivative of d by dx of denominator. What is that beta? X square plus 3x minus 18 plus mu. So it will come out at 2x minus 3 is equal to, check here beta, it is lambda. When we differentiate it, it will come out as 2x plus 3 and then plus mu. It will be 2x minus 3 is equal to beta. I have to multiply this lambda to this 2. It will be 2x lambda x plus 3 lambda plus mu. Now I will compare here the coefficient of x and the constant term. What I will get beta? I will get here compare quotient of like terms. So I will get here beta 2 lambda is equal to 2 because the coefficient here is coefficient of x is 2 and the coefficient of this x is 2x lambda. So it will be a lambda again, it will be lambda is equal to 1. Now when we will compare the constant, we will get beta 3 lambda plus mu is equal to minus 3. 3 lambda we have 1 plus mu is equal to minus 3. So mu is equal to beta, this 3 1 into it will get to this side minus 3 and mu we get minus 6. So we got two things here. We got the value of mu as well as this lambda. When we are substituting this we get 1 and mu we got equal to minus 6. Now we will make this substitution to our integral, to our I. Therefore beta I equals to x this 2x plus 3 minus 6 divided by x square plus 3x minus 18. This it will be further equal to beta 2x. We will now give this denominator both this 2x first and this one, it will be equal to beta I is equal to is this possible beta? Yes, of course beta, because 2x plus 3 minus 6 that will come out as minus 3 and this will be equal to beta. This will be further equal to, I will write here 2x plus 3 divided by x square plus 3x minus 18 dx minus 6 integral of dx divided by x square plus 3x minus 18. This you know how to solve. It's not quadratic. You can make the method of completing the square here and to get the solution of this. Now beta, how we can solve this? Now you can solve this easily by this method of substitution beta. You have to substitute now this denominator x square plus 3x minus 18 to some parameter, that is t beta. When you will get 2x plus 3 dx is equal to tt. That is the numerator, and denominator will get t. It will be log of this, and this is now easy beta. You can do it by yourself. So Now if we have beta, again this as a form of this, but we have this quadratic equation under in under root. So how we can, you have to apply the same procedure, same method. You will get here this, but in under root, as you know that how to solve this by when it is in under root, and you will get here beta like this. You have to substitute there beta this one to t to some parameter. You will get the solution. Now it is n beta. We will make it here n, and we will go for the method of integration by parts. That method we will solve tomorrow beta, because that is very beautiful method and best method. It was just some extension of this substitution method beta. Now we will go for the method of integration by parts, and that we will follow tomorrow inshallah. Now it is enough today.